8, we looked at exponential growth and decay. So let's draw an example of an exponential growth function versus an exponential decay function. Exponential growth, it starts out growing really slowly, but then all of a sudden it grows really quickly. Decay is the opposite. It decreases really rapidly and then kind of levels off. So there's exponential growth and exponential decay. We looked at equations with percentages. So an example of exponential growth, you have $500 to invest into an account that gives you 1.5% per year. Write the equation that represents this information. So for exponential growth and decay, we start with the starting value, y equals 500. If it's growing, we have 1 plus. We're going to change 1.5% to a decimal, and you can do that by dividing by 100 or moving the decimal place to the left twice. So this would be 0.015 to the x power. So when you write exponential growth or decay, it's y equals ab to the x, where a is your starting value, b is your growth or decay factor, and x is usually time. All right, let's do a decay problem. An initial population of earthworms in a garden is 55. You find that the population decreases at 7% a year. Write the equation that represents this information. So we have our starting value of earthworms is 55. If it decreases, it'll be 1 minus 7% a year. So again, change 7% to decimal, divide by 100 and move the decimal place over twice to the x power. How many earthworms will there be in your garden in 4 years? Well, that's time. You're going to plug that in for x. So if y equals 55, 1 minus 0.07 for 4 years. And then you're going to type that in. So I'll pop up my calculator and type that in. Let's write C while we wait. How many years will it take for there to be 33 earthworms in your garden? So this time you have the number of earthworms. 33 equals 55 times 1 minus 0.07 to the x. So this will be guess and check. We want to figure out, all right, what does x have to be so that we get 33? All right, let's go back to B though and type in. Just do scratchpad here. Okay, so we're back at B. We're going to type in 55, 1 minus 0.07, and then go to the outside of the parentheses to the power of 4. So after 4 years, there's about 41 earthworms. So then for guess and check, this is decaying, so we know it's going down, so it's going to be more than 4 years. So let's try 5 years and see if we get down to 33 earthworms. So 55, 1 minus 0.07. Let's try 5 years. Let's try 6 years. Seven years. You can see it takes about 7 years for there to be about 33 earthworms. So here we're going to say x equals 7 years. Number 5, identify the function as growth or decay, and then find the growth or decay rate. So this is growth because this number, the second number here, the b value is bigger than 1, and it's growing by 7%. Last year, your family bought a car for $9,500. The value of the car goes down 5% a year. What's wrong with this equation? Well, we know the decay rate here has to be 1 minus 0.05 instead of just 0.05. Number 7, just review properties of exponents and finding a common base. So for the first one, we're going to multiply our numbers together. Base is 5 and 4. We get 20. Then we have 3 x's here and 8 here, so we have 11 x's total. If you have 7 x's on top and you cancel with 9 on the bottom, you're left with 2 on the bottom. Another way to write that is x to the negative 2 power. Here you're going to distribute the 4 to all the exponents, so it's 5 to the 4th, x2 that we're going to distribute and multiply, x to the 12th, y to the 8th, and 5 to the 4th power you can calculate as 625. The next one, we'll divide our numbers first. 20 divided by 4 is 5. You have 3 x's on top and 2 on the bottom, so when you cancel, you have 1 left on top. You have 1 y on top, it cancels with 1 y on bottom, so you have 10 left on the bottom. Right here, find a common base. 5 to the 3rd power equals 5 to the x power. Once you find a common base, ignore the base and set the exponents equal. So here x is 3. Let's do the same thing over here. The bases are the same, so ignore them. And you have x plus 2 equals 3x minus 4. And this is just an equation that you're going to solve. You'll subtract x from each side. You get 2 equals 2x minus 4. We'll add 4 to each side. I'll do the rest of the work up here. So we'll add 4, we'll get 6 equals 2x. Divide by 2, so x equals 3. So there's a review of chapter 7 and 8, and we'll do more final review in the next few podcasts.